Hi, future doctors. Welcome to the next class. In this class, we will discuss about equipotential equipotential surface. So, what is equipotential surface? In the name itself, it is going to be there. So, the surface which is having same potential, the surface which is having same potential or equal potential. We are calling it as equipotential surface. If you are taking a positive charge, point charge, so at some distance r, at some distance r, at each and every point, at some distance r, at each and every point because of this charge, what is the potential equation we came to know? Kq by r. So at each and every point, the potential is going to be same. Now this surface, we are calling it as equipotential surface. At 1, at a 2, at a 3, at a 4. At all these points, potential is going to be same because of this charge. Therefore, this surface we will call equipotential surface. If we are taking another distance, so let us assume that is going to be r dash. Now, at this distance r dash, again, potential is going to be same. Now, what is the potential on second surface? Kq by r dash. So, this is surface B. So, initial one is surface A. So, potential at A, potential at B. So, VA, VB dash or VB, we can take potential at B, Kq by r dash. Now, so VA, surface A is going to be one equipotential surface. Surface B is another equipotential surface. So in this direction, if you go like this, for positive charge, already we came to know, for positive charge, what is the direction of the electric field? Direction of the electric field is always away. So if you are taking 2 points, A and B. So if you draw equipotential surfaces at A and also at B, these two are equipotential surfaces. For point charge, equipotential surfaces are always circular, isn't it? Now, what is the direction of electric field? Direction of electric field is always for positive charge away. This is the direction of electric field. Now we are taking 2 points. One is R, another one is R dash. Potential at A, Kq by R. Potential at B, Kq by R dash. Where potential is going to be more, at A or at B, means because of this positive charge. If distance increases, potential value is going to decrease. Therefore, VA is greater than VB. So you got one point, that is in the direction of electric field. In the direction of electric field, what happens to potential means potential decreases. So through this distance from A to B, let us assume dr, we will take r dash minus r. So what is the potential difference means? So through distance dr, potential difference is dV. Okay. So generally we will write dV by dr. So what is this dV means? VB minus VA. VB minus VA. dr means r dash minus r. So already we said VA value is going to be more. Therefore, less value minus more value gives like this, minus dV by dr. This value we are calling it as negative potential gradient. So what is potential gradient? One new word you got, but this is already you got in your first year. Potential gradient. How you got in first year means velocity gradient. Velocity gradient. Another one is temperature gradient. See, you got three gradients. Now we will define what is potential gradient. Very simple. If potential is changing with respect to distance, if potential is changing with respect to distance, potential gradient. If velocity is changing with respect to distance, velocity gradient. If temperature is changing with respect to distance, that is temperature gradient. If you people are changing with respect to distance, that is your gradient we will define. So therefore, negative potential gradient we will define as electric field. So now electric field intensity, another definition, E is equal to minus dV by dr. Very, very important equation. So dV is equal to minus EdR. So they will do integration on both sides to get potential. So V is equal to minus EdR. Very, very important equation this one. And electric field intensity is a vector quantity. In vector notation, they will write like this. E bar is equal to Ex I cap plus Ey j cap plus Ez k cap. So this one, how they will write in terms of this one means minus dV by dx I cap minus dV by dy j cap minus dV by dz k cap. So this one only they will write dou v by dou x, dou v by dou y, dou v by dou z. So that is called partial differentiation we will be saying. So very, very important formula. Now electric field intensity, another definition is negative potential gradient. Now relation between E, V and R because of point charge. If you are taking one positive charge, point charge at some distance R, what is the electric field intensity at this point P means E is equal to KQ by R square. So what is the potential at this point P means KQ by R. So from this equation, KQ by R into 1 by R. So what we can write in place of KQ by R? V by R. So this one only will write electric field intensity, V by. So potential by distance. Potential by distance gives electric field intensity. So this is about equipotential surface. Next up. On the surface, what we said, potential is going to be same. At point 1 and point 2, potential is going to be same because distance is going to be same. So if you want to bring a charge, capital Q, from 1 to 2, what is the work done? So what is the work done formula we give generally? Q into VA minus VB. So W is equal to Q into V1 minus V2. So because of point charge, so on equipotential surface, if you are bringing one charge from 1 to 2, capital Q if you are bringing, capital Q, potential at 1 minus potential at 2. So V1 minus V2, but both the potentials are going to be same. Therefore, work done is 0. Therefore, this property they will say, work done to move a charge on equipotential surface is always 0. Not only 1 to 2, so 1 to 3, so 1 to 4, so 1 to 5. So like this they will ask W1, W2, W3. So what is the work done among all these cases means work done is 0. To move any charge on the equipotential surface, work done is 0. Sometimes they will move the charge from one surface to another surface. Now you have to do work done. That one only we will write VA minus VB, another potential surface. Here potential difference is going to be present. Therefore, you have to take care about that. They are bringing charge onto the same surface or they are bringing charge onto the another surface. You have to see whenever they are asking the question. Isn't it? Now, Two properties you got. One is work done is zero to move a charge on same surface or equipotential surface. Next, another point is electric field intensity is negative potential gradient. Another point you should come to know, in the direction of electric field, potential is going to decrease. So that point also you got. So if you are taking positive charge, so if distance increases, potential value decreases. Means in the direction of electric field, potential decreases. So V is equal to KQ by R. From this formula we can say if R increases, V decreases. But you got another point that so in the direction of electric field, potential value decreases. Now they will ask some questions whenever they're asking or giving values 10 volts, 20 volts, 30 volts, 40 volts like this they will give. At the time, what is the direction of electric field? What is the direction of electric field means electric field is always in the direction of potential decreases. In which direction potential is decreasing? Towards left side. Therefore, electric field intensity will be having direction minus I cap. So same question they will give minus 10 volts, minus 20 volts, so minus 30 volts, minus 40 volts. Now, which is direction decreasing means right side it is going to decrease. So E I cap. So 0 volts like this. So in the direction of decreasing potential, isn't it? In the direction of decreasing potential, electric field intensity is going to be present. So in problems case, this is going to be very helpful. So you have to observe these things whenever they are going to give the questions on this equipotential surface. So main 2 points, work done is zero. Another one is electric field intensity is negative potential gradient. So in next class, we will discuss questions problems on this E is equal to minus dV by dr. Okay.